Okay, what's up everybody? This is Rational Functions number 3. This time is on graphing. This is the one that we struggled with most on the test, all 3 classes, all classes throughout the school, actually, so let's have a good review of this. So, rational functions, a function in the form of f of x is equal to p of x over q of x. So, this is when we have a polynomial divided by another polynomial, which makes it a rational function. P of x, so P of x and Q of x are polynomials. And, just a plus, Q of x cannot equal 0, okay? All right. You're given steps with this one too, which I think will be very helpful. So step 1, simplify the function. Factor what you can factor, do what you need to do. Step number 2 is finding the x-intercept by... Is first period over?
In 5 minutes.
Okay. 2, find the x-intercept by setting the numerator equal to 0. 3, find the vertical asymptote by setting the denominator equal to 0. Find the horizontal asymptote using the rules below. So the horizontal asymptote is the difficult one. Remember, we talked about how you could sum this all up just with division. If you divide the 2, it'll tell you what it is that you have. So if P is greater than Q, we determine that there was no horizontal there's no horizontal asymptote, okay? So this is where you had like a slant. So there might be a slant if it's 1 bigger, a parabola if it's 2 bigger. So these were our improper cases, okay? And you would divide and you would get the slant asymptote or whatever. Second case, P is less than Q. So this is our proper case. So when it's proper, we have it's the x-axis, or y is equal to 0. And then when the 2 of them are equal, it is the y equals the leading coefficient of p of x divided by the leading, I don't want to write that word again, coefficient of q of x. Okay, and then lastly, you want to identify any holes in the function. I want to do one with a hole real quick. So let's go down and quickly do 3. So for 3, I'm going to turn this, first thing I'm going to do is simplify. Okay, so I'm going to have f of x is equal to x plus 1, x minus 1, wait outside for just 2 minutes, divided by x minus 1. Okay, so what we're going to have now is we are going to have a hole because we have this situation right here where you have the same factor on the top as the bottom. That's what makes a hole. Okay, so this has a hole at the number 1, because what would make this 0? It would be 1, okay? Now, what they're talking about here, and I'm going to have to wrap this video up pretty quickly because people are starting to come in, as I'm sure you can tell. So to find the x-coordinate, set the common factor equal to 0. So our common factor was x minus 1. Now, if you do set it to 0, do you see how we get 1? That's all that's talking about. Okay, you set it equal to 1. Now, to find the y-coordinate, substitute the x-coordinate into the simplified function. So our simplified function is f of x is equal to x plus 1 because these 2 went away. So you need to substitute, okay, we know it's undefined or there's a hole at x is equal to 1, but what about y? Well, what this is saying is you need to substitute 1 in for x, and what's 1 plus 1? 1 plus 1 is 2. So when x is 1, y is 2, and that's your hole. And then what's left over is just your simplified function, which is x plus 1, which is a graph right through here. It's actually going to be linear with a hole at 1, 2. Okay, I was hoping to make this video a little bit longer, but I can't. So let me just fill in the rest of the information for this one. So our x-intercept is going to be, just one moment here, our x-intercept is -1, 0. Our vertical asymptote is none. Our horizontal asymptote is none, okay? Because it just is linear. And then our hole, we determined to be 1, 2. And the domain, you could say everything except 1. So you would say like all real except the number 1. And the range would be all real except what? The number 2. Okay, take it from there and